Let us start this lecture with a thought process: creativity can be manifested on the soil of solitude. Unfortunately, today the modern people do not understand the efficacy of staying in solitude, and therefore, creativity of individual is being hampered as people are running after the material gains without really thinking. And let us recall that what we had learned in the last lecture. If you remember that we had basically a discussion about the liquid fuel combustion. In that, in the beginning we started with the droplet combustion, and later on we moved to looking at briefly how to handle the spray combustion. A spray is basically an array of the droplets of various diameter, but we handled earlier for monodisperse droplets. So, today we will be basically initiating a discussion on the solid fuel combustion. A lot of question might be coming to your mind that why we need to look at solid fuel combustion. Keep in mind that the solid fuel combustion is as old as our civilization. Indian civilization is the oldest civilization among all. People might have seen the natural fires occurred due to the solid fuel, particularly in forest, and they might have learnt how to handle the fire and how to control the fire and use it for the development of the various kinds that will help people to lead a good life. So, therefore, we always worship the fire god, what we call it Agni. So, therefore, the most natural combustion one can think of that occurs in nature is the solid fuel combustion, particularly from the biomass. And now, in present context, the solid fuel combustion is very important even today, although it is quite complex to initiate the combustion with the solid fuel, as I had told earlier. And the most easiest way to have a combustion, particularly the clean combustion with the gaseous fuel, and of course, then there will be a liquid fuel. The most difficult to have a controlled combustion with the minimum emission, which is the need of the hour, is basically solid fuel combustion. However, we do use it profusely even today because of various reasons, and as we go along we will discuss. You please ask the question to yourself why we need to use the solid fuel, although it is difficult to handle. So, far combustion is concerned. Let us look at the various applications of the solid fuel combustion, and if you can really scratch your mind, and you will find that coal burning is very important, which is being used for various energy devices and power plant, even in domestics and other things. The burning of coal is very important, particularly for us in India, because of fact that India is having a very large reservoir of coals. Unfortunately, Indian coals is having peculiar problems of higher ash contents. Now, we need to develop the technology for it. Unfortunately, we just get the technology from outside and then face various problems. So, the coal combustion is very important, and beside this, the biomass burning is also one example of the solid fuel combustion. And keep in mind that coal is unsustainable because of fact that it is having a fixed reservoir, whereas the biomass is basically sustainable in nature. And according to me, that man might have really looked at the biomass combustion, and that culminated into a fire which might have really generated lot of interest in the minds of the people, particularly during forest fire, which has been described very well in our olden scriptures. So, therefore, it is very important, and today people are talking about biomass combustion, gasification and pyrolysis, and it is a very hot topic, and earlier also people were using it. And beside this, the solid fuel is being used basically as a refuse fuel, because of fact that there are several material which can be really being thrown out. It can be used like a municipality waste, and then some other waste kind of materials can be utilized for burning, and so that we can get power and heat energy and other things. And metal combustion is very important application, particularly in the field of metallurgy for processing industries, and that is also important. It is also important in other application like in propulsive devices and other places. So, there also solid fuel is being used. Another application is the carbon combustion, which is very important. Of course, it is the only pure carbon, it is not hydrocarbon as such, but carbon combustion is also very important. So, beside this, the solid propellant combustion, which is being very much used, particularly for missile application and space applications and other things, and now it is quite an important thing to have a say in the international arena. So, therefore, the solid fuel combustion is very important. Let us look at like related to all these 5 aspects, that the solid fuels are being used for generating powers, particularly in stationary power plants, and there is another great application for the space propulsion, as I told, in the rockets and the spacecrafts, in the missiles and other places. Of course, the domestic application, cooking is one of the important one. Beside this, the room heating and other places, solid fuels are being used profusely. Beside this, that you will have to also use for the reheating system, even for refrigeration systems one can use the solid fuel, and several other application one can think of. Of course, the solid fuel is not really being used very much for the transport applications, because of problems of that how to handle the fuel, particularly the flow of the fuel into the engine is very important, and also the some of the particulates which will be coming out unburnt, and then how to handle that, and that is the reason why it is not being used. And of course, another important reason is that there are several exotic fuels like your petroleum products like kerosene, diesel and other fuels, and so also the gaseous fuel CNG, LPG are available plentifully due to the era of petroleum as we are living. So, therefore, it is not really being utilized. However, wherever there is a stationary applications and where is used, then we go for the solid fuel. Question arises, why we will go for solid fuels, why not liquid or the gaseous? Because of reasons that it has a higher density in comparison to the other fuels like your gaseous fuel or the some of the liquid fuels as well, and it has a higher flame temperature as compared to the other liquid and gaseous fuel. Beside this, it has a sometimes of course higher heat of combustion as compared to other gaseous and liquid fuels, and it is easy to handle and store, unlike the gases, which is very quite dangerous, because any leakage from the gas tank or the pipeline can create havoc, particularly when the people are living around. And so also the liquid fuel, it vaporizes, it may lead to explosion, it may lead to fire and other things, and it is very easy to store the solid fuel as compared to the gaseous and liquid fuel. And it is readily available, as I told, the coal, the biomass are easily available at a cheaper price, and it can be transported easily. So, therefore, it can be used, and let us look at what are the factors that influence the solid fuel burning. If you look at, really basically it is the nature of the solid fuel. As I told earlier, the coal may be containing large amount of ash, as in India. The ash content varies from 20 to 40%. That means you are carrying the fuel which is having large amount of material which cannot be utilized. It is just a ash. And beside this, biomass also is another fuel where it will be changing, because these are all natural fuel, like its constituent will be changing depending on what kind of biomass you are using. And but of course, you can design your fuel, solid fuel, like your propellants and maybe some kind of coke and other things. So, there when you design, you can densify the fuel and you can have a higher calorific values also, and also it depends on the type of application one can have. For example, you want to apply it for a stationary power plant, and you can very easily really transport it and use it, particularly making powder, so that the intensity of combustion can really be higher in the boiler. But when you are using domestic, you are not bothered about intensity of combustion higher, whatever it is required, but the heat liberated rate, or the rate of heat of combustion is really not that important in domestic application. You can use a bigger size. Of course, if it will be too big size, then your combustion may not be good, and then it lead to the pollution, other thing. So, therefore, the kind of applications will dictate the how the solid fuel is getting burned, and what are the processes involved during the combustion of a camphor and naphthalene. Of course, I am taking an example of camphor. Camphor is a part and parcel of our culture, because we use the camphor for our rituals, and everyday worshipping we use that. And you might have seen particularly a camphor fire, what I have shown here. These are the camphors, right. And there is a basically a flame we could see. And naphthalene, of course, is a petroleum product which is being used for various purposes in modern life. And if you look at, you just ignite this camphor or initiate a fire on this, and then it looks to be a very nice fire and with a yellow flame. And of course, it is a little bit sooty in nature, and but what are the processes involved in that? If you look at, basically the camphor can melt into a liquid initially, you might have observed, and therefore, getting the heated by like your mastic or some other kind of naked flame for initiating the combustion of camphor. And once it is liquid is being formed, and that liquid subsequently is converted into its vapor and undergoes basically vaporization process. And once it is its vapors are formed, it mixed with the certain oxidizer which present in the air in the atmosphere. And then of course, the combustion flame will be occurring, but and there are certain fuel which is directly converted into gas when subjected to heat. And combustion, as I told earlier, the combustion takes place in gaseous phase mostly, therefore, the flame you could see, this is a flame. And really what happens in that? The flame is generally established at certain distance above the solid surface. If you look at this is the solid camphor, and as a result the heat will be transferred from this flame to the solid camphor, such that it will be melted, the gas is being produced, and then you can really get a flame whenever this gaseous fuel is mixed with the oxidizer due to the diffusion process. So, let us look at what happens in a candle flame, which is basically petroleum wax what we use, and day to day life we use that. Here it happens similar things like let us say this is your wick, which is being, this portion is your wick, which carries basically the fuel along with it due to the capillary action, provided there is a melting wax. So, this is your melting wax, right. This portion is your melting wax, or in a liquid form. This is in a liquid form. You might have observed this, and this basically then what happens, this is liquid being generated due to the flame, and a flame is formed. But in the beginning, as I told earlier, that you will have to use a naked flame for burning this wick, and that wick will be giving some heat to this wax or the candle, and which is converted into liquid, and this liquid will be going up with the help of wick due to the capillary action. Then that will be converted into the gaseous, this liquid will be converted into gaseous undergoing the pyrolysis process, and the fuel will be going towards the oxidizer in the air. This is your air in atmosphere, right. And then the air also will be getting into the flame, which is here, and then they mix together and the flame is formed. So, this is your flame which is being formed, and this contains a certain amount of carbon particle, what we call soot particles, and beside this there will be carbon dioxide and water which are being formed due to the combustion of hydrocarbons with the oxygen, and then it will be going. So, if you look at this, is basically the process is quite complex as compared to the gaseous fuel. Here the process of vaporization and also the pyrolysis and some of the gasification will be taking place. So, let us now summarize what are the processes involved in the solid fuel. So, as I told earlier that the solid fuel, whenever it will be subjected to the heat, and the it will be solid can be converted directly into gaseous fuel undergoing basically the pyrolysis process, or the solid fuel will be melted into the such that the liquid fuel is being formed, and it can go directly gasify into the gaseous fuel, and once this liquid is formed, it can be evaporated, or which can also be undergoes pyrolysis process and converted into gaseous fuel. So, there are the various ways the solid fuel can be converted into gaseous fuel, and it will be mixed with the oxidizer and then only the combustion can take place. Keep in mind that the pyrolysis is basically a process by which the fuel is decomposed whenever it is subjected to the heat. So, therefore, what we will be looking at now, what are the process difference between solid fuel volatilization, because whenever the solid fuel is there, it has to convert it into liquid, it can convert it into the gaseous way, and whenever it will convert into gaseous, we call the volatilization, because the solid fuels which will be containing lot of volatiles which can really convert into gas at a little higher temperature. And the liquid fuel of course will have to vaporize, it will be converted into gaseous phase. Now, what is the difference between both the process which looks to be similar in nature? The liquid vaporization is basically a surface phenomena. That means, it will be occurring at the surface of the liquid droplet. If this is a liquid droplet, and it will be occurring at the surface, like this is a surface, right. So, this is basically a surface phenomena, whereas, if it is a let us say a carbon sphere which is having a undergoes volatilization or the gasification, then what will happen? It will be occurring at the inside it. Suppose this is a carbon, right, particle which is a solid. Now, it will not get into, but suppose if the heat is subjected to heat here coming from this side heat, then naturally in this zone there will be some devolatilization will be taking place, or volatilization will be taking place. So, and this is a basically volumetric process. So, that is very important, one has to keep in mind. So, as I told earlier, the stages of solid fuel combustion, basically it can be divided into two. First is the it get volatilized, that means some of the solid will be converted into gas, and then after that whatever it will be remaining, that will be undergoes a Char combustion. Of course, there are certain kind of solid fuel which will not undergo any volatilization and directly undergoes the combustion. So, that is kind of fuel which will be particularly the carbon, if we were only pure carbon, that will be undergoing, and in such kind of fuel, solid fuel which will be undergoing the volatilization, that is known as pyrolyzing solid fuel. And is the Char combustion or homogeneous and heterogeneous in reaction? Actually, when you talk about Char combustion is basically the heterogeneous reaction and undergoing the in which the chemical reaction undergoes in the condensed phase. For example, fuel is the solid and a gas will be getting into the solid, and then will be getting this solid phase or the condensed phase combustion will be taking place. As a result, there will be glowing combustion, you will see particularly if you see the cindered carbon, right, charcoal, right, charcoal or carbon, you will find the similar kind of image which is a glowing in nature. So, therefore, you will be getting that it is basically the what you call Char combustions, right. And let us look at, as I told earlier, let us say there is a solid fuel here, of course, the whole thing is solid fuel and it is subjected to the heat from various regions, right. And in the beginning it may be a solid only, and then after that what happens, it will be undergoing the volatile the gases will be going out as it is being formed in this region, these gases, and that became basically carbonous residue. This is the carbonous residue which will be remaining. And of course, this one what I have shown is basically the virgin solid, which is not subjected to any kind of combustion, or no changes occurs in this, because that is why it is virgin. And gas flow will be taking place, and these gases which will get into here, and it will be mixed with the oxygen or oxidizer, and then a flame is formed, and the flame will be giving heat, and so that process is going on. Such kind of process you call it basically the pyrolyzing solid fuel combustion. Then a question might be arising in your mind, what are the factors affecting the production of interior gases? These are interior gases which are produced, and that basically depends on the amount of heat is being transferred. The amount of heat transfer is basically depend on how far the flame standoff distance. So, if you look at this is the flame standoff distance. That means how far it is from the solid surface, and also it depends on amount of incident heat flux on the solid surface, which is dependent on the quality and quantity of the gas which is being generated. This gas which is being generated here, right, this will be getting into transferred to the flame, and therefore, the flame standoff distance depends on the amount of gas generated and also the quality of the gas. Therefore, that is very important. So, and there is another kind of combustion which will be, or the thing which will be taking place basically for the carbon. This is your carbon, where the solid fuel will not undergo any pyrolytic process, and but however, it will produce on the surface the gas, and then it will be gas will mixed with the oxidizer in the atmosphere, and then flame is being formed. And this is possible only for certain fuels like a carbon, boron, titanium, silicon and zirconium. These are the metals, and this is of course, for other metals the pyrolyzing combustion will be taking place, what I have shown here. And this is possible only when the boiling point temperature of metal oxide is less than the boiling point of metal, and that is basically when non-pyrolyzing combustion will be taking place. Pyrolyzing combustion will be taking place when the boiling point temperature of metal oxide greater than the boiling point temperature of metal. So, with this I will stop over. Thank you very much, and we will be discussing more about in the next lecture. Thank you very much.